We are moving into Chapter 9, Chemical Reactions. There are 3 sections in this chapter: reactions and chemical equations, classifying chemical reactions, and reactions in aqueous solutions. In Section 1, we are responsible for learning to be able to recognize the evidence of chemical change, represent chemical reactions with equations, and be able to balance those equations. Remember the difference between a physical change and a chemical change. Chemical change is what we're looking for when we have a chemical reaction. Remember that a chemical change is a process involving one or more substances that change into a new substance. When we have a chemical reaction, we always have a new product that is formed. The vocabulary for Section 1: chemical reaction, reactant, product, chemical equation, and coefficient. The main idea for this section: chemical reactions are represented by balanced chemical equations. Okay, what is a chemical reaction? It is the process by which one or more substances are rearranged to form different substances that are. Remember, the reason we have chemical reactions is because all the elements are trying to have 8 in their outer shell. They're trying to fulfill that octet rule. If they don't have 8 in their outer shell and that valence electron, they're not happy. So they are going to chemically react or cause a chemical reaction until they get to be happy. What evidence have you seen in chemistry class this year that proves that a chemical reaction has occurred? Think about all the things we've done. If you have a change in temperature, remember we talked about endothermic and exothermic. Endothermic means that it's taking in energy from the environment and the beaker is cold. On the other hand, exothermic means it's giving off heat, so the beaker is going to be hot. A color change, think about when we have done reactions that have produced a color change. And the easiest one that we've done to remember is the bubbles that form. Vinegar and baking soda, when you put those together, everybody makes the volcano, right? So you have all those bubbles and gas that are formed. Okay, so how do we represent chemical reactions? Chemists use statements called equations to represent chemical reactions. Everything on the left-hand side of the arrow or the equal sign are called reactants. That's what you start with. Everything that is made or produced is on the right-hand side of the equal sign or the arrow, and that is called a product. So the reactants on the left, the products on the right. And we are going to be using these symbols, so please become familiar with them. You're going to put a plus in between your reactants. You're going to have an arrow, which means yields, or sometimes you'll see an equal sign. If you see a double arrow, it means that the reaction can go both directions. It's really important that you put the state that the element is in, if it's a solid, a liquid, a gas, or aqueous in a water solution, behind the element, and we're going to get practice with that. Okay, so the first thing you need to do is write out the equation in words. Okay, so here we have aluminum and bromine react to produce aluminum bromide. So we have aluminum, that's a solid, there's that plus sign, plus bromine, that's a liquid, yields or produces aluminum bromide, which is a solid. Okay, so now the next step is to write out the words into the chemical formulas. Okay, so you have aluminum, which is a solid, please remember to put these in here, plus bromine, which is a liquid, yields aluminum bromide. See how this is balanced? Okay, which is a solid. So you guys have practice writing these words, just like when you were in elementary school and you were learning how to write sentences. First you had to learn to write and spell the words. Now you can put the words together to make a sentence, which is what we're doing. You know how to balance these out. Okay, now we're going to balance out the whole sentence. Skeletal equations lack information about how many atoms are involved in the reaction. So now we have to learn how to balance the whole equation. Okay, so a chemical equation is a substance is a statement that uses chemical formulas to show the identities and relative amounts of the substances involved in the chemical reaction. Okay, so let's look at this one again. Aluminum, which is a solid, we have bromine, there's two of them, is a gas, and when they combine, it is AlBr3. So there's three of them and they are solid. Okay, so you can look here. You have one aluminum coming together with two bromines. Now to balance this out, you guys know how to balance these. This, you have AlBr3. This is balanced according to its oxidation charges. So you have three bromines and you have one aluminum. So we have a total of 4 atoms. Okay, but the equation still is not completely balanced. Okay, we have to put what you call coefficients, these numbers in front of your chemical compounds to be able to balance the equation. So if we go back, let's go back one here, you can see that this is the reactant side, this is the product side. Over here we have one aluminum. On the product side we have one aluminum, so that is balanced. On the reactant side we have 2 bromines. On the product side we have 3 bromines, so those are not balanced. We have to add a coefficient in front of somewhere, one of these, to balance that out, 1 or 2 of them. Okay, so that's what you have to play with, is figuring out which one needs to have coefficients added. And they've actually done this one for you. So if we add a 3 in front of the bromine, that gives us, you have to multiply these together, that gives us a total of 6. So we know we have 2 bromines over here, or excuse me, we have 3 bromines, so we have to add a 2. And you cannot put the 2 in the middle, it has to go in front of the word, okay, in front of this whole chemical compound. So now we have 6 bromines. Now our bromines, we have 6 here and 6 here. That is balanced. However, we now have 2 aluminums, so we have to add a coefficient of 2 on the reactant side to make sure that is balanced too. So when you look at the entire equation, you have 2 aluminums plus 6 bromines yields 2 aluminums plus 6 bromines. The law of conservation of mass or matter. Okay, so here's the definition of a coefficient. It is in a chemical equation. It is the number written in front of the reactant or the product describing the lowest whole number ratio of the amounts of the reactants and products. It's the number that you multiply by to see how many atoms there are total. Here are the steps to follow to balance an equation. So number 1, write out the skeletal equation for the reaction. Make sure that the chemical formulas correctly represent the substances. An arrow separates the reactants from the products, and a plus sign signifies or separates multiple reactants and products. Show the physical state of all reactants and products. Number 2, count the number of atoms of elements in the reactant. If the reaction involves identical polyatomic ions in the reactant and product, count each polyatomic ion as a single element. This reaction does not involve any polyatomic ions. 2 atoms of hydrogen and 2 atoms of hydrogen, 2 atoms of hydrogen and 2 atoms of chlorine are going to react. Next, count the number of elements in the product. 1 atom of hydrogen and 1 atom of chlorine are produced. Number 4, change the coefficient to make the number of atoms on each element equal on both sides of the equation. Never change a subscript. That's really important. You're going to do that once or twice by mistake. Everybody does. Okay, then you learn. So never change the subscript. The only way to balance the equation is to add or change coefficients. Okay, so let's try a couple. Okay, we're going to go on and try a couple here. Okay, the most fundamental law of chemistry is the law of conservation of mass, or the law of conservation of matter. The products must equal the reactants. Okay, so let's practice. You're going to write a balanced equation for each reaction. So the first thing, here is your first one. Hydrogen and bromine gas react to yield hydrogen bromide gas. So you're going to have hydrogen, which is a gas, plus bromine, which is a gas, yields hydrogen bromide. Now we need to put that into the correct chemical formula. So you have hydrogen 2. Remember, this is a diatomic. It cannot be by itself. So hydrogen is 2, bromine is 2, and then we have 8 yields HBr. Now, we need to balance the entire sentence, balance the entire equation. The reactants must equal the products. Here we have 2 hydrogens, here we have 1. Here we have 2 bromines, here we have 1. So we must add a coefficient to make the law of conservation of matter or the law of conservation of mass balance out. Okay, so the easiest way to do that is to put a 2 coefficient of 2 in front of the product. So now we have 2 hydrogens on the reactant side, we have 2 bromines on the reactant side. On the product side, we have 2 hydrogens and we have 2 bromines. Okay, now this one you get to try on your own. In water, iron 3 chloride reacts with sodium hydroxide, producing a solid, it's supposed to be iron 3 hydroxide sodium chloride. Okay, so let's write it out. So we have iron chloride reacts with sodium hydroxide, aqueous because it's in a water solution, yields iron hydroxide plus sodium chloride. Now you have to balance. So you have 1 iron on this side, 1 iron on this side. You have 3 chlorines on the reactant side, and you have 1 chlorine on the product side. So that's going to need attention. We're going to need to work on that. Okay, another thing you need to look at, we have these are each individual elements, and that's what you need to look at, not the polyatomic, but each individual element. So you have, on the reactant side, you have 1 hydrogen. On the product side, you have, remember, this is in a parenthesis, so you have 3 oxygens. So that is unbalanced. You have 1 hydrogen on the reactant side. You have 3 hydrogens on the product side. So that is going to need attention as well. So we have to add coefficients to get this to balance out. So we end up with FeCl3 plus 3 NaOH yields FeOH3 plus 3 NaCl. You're going to get it. It just takes practice to figure out which coefficients go where. But we have to learn how to balance equations before we can move on and learn the types of chemical reactions. Okay, here's a nice little flow chart to help you when you're learning how to balance chemical equations. Okay, step number 1, write out the skeletal equation. Okay, make sure that you put the reactants on the left-hand side and the products on the right-hand side. Step 2, count the number of atoms in the reactant, count the number in the product. Step 4, add or adjust the coefficients, number the atoms on the number of atoms of each element on the left-hand side, number of atoms of each element on the right-hand side must equal. Okay, if they don't, you have to add those coefficients. Make sure the coefficients are reduced to the lowest possible. Okay, and then go back through and double check your work. Answer is and the answer is. Okay, don't worry about this. We are going to get lots of practice with balancing equations.